In this class, we are discussing about black holes. We know the Chandrasekhar limit is 1.4 m sun. And we also know that between 1.5 m sun and 10 m sun mass of star, the star becomes a neutron star. That is, any star having a mass greater than 1.5 m sun, it has a chance to explode violently. And finally, this range of mass stars, 1.5 m sun to 10 m sun, such explosion of stars leads to a stable neutron star of density varying between 10 raised to 14 to 10 raised to 15 gram per centimeter cube. If the original star is more massive, such a star does not explode. Instead of the explosion, it will contract. And these massive stars quickly use up their nuclear fuel. Their lifetime is about 10 raised to 7 years. During contraction, it is getting to cool down. So star contracts again and again. So during this cooling, during this contraction, its potential energy is transferring to heat, and the star continues to collapse with a very high speed. If the star cannot speed off most of its mass, the collapse continues with increasing its speed. More and more intense gravitational field is produced. So gravitational field increases and decreases. At the same time, the size of the star is reducing more and more. So this is a picture which shows the surrounding mass is attracted by the contracting star, which becomes a black hole. And in this process, a particular stage of radius is reached when the radius of the star of mass m becomes Rs equal to 2gm by c square. Here, Rs, the radius of the star, is called Schwarzschild radius. For g is the gravitational constant, and m is mass of the star, and c is velocity of light. When this radius Rs is reached, the object will have such a strong gravitational field. It will prevent even light from escaping out of its influence. We know in Newtonian mechanics, we can say that at Rs, the velocity of escape from the object is equal to velocity of light. We also know that no particle is having a velocity which is greater than the velocity of light. So no particle will escape from the gravitational pull of the black hole. Even photons cannot escape. So we cannot see the black hole because we are seeing an object by reflecting these photons. Here, photons are also absorbed by the black hole. So we cannot see the black hole. So no event takes place within a radius Rs can be communicated to outside. So we don't know anything about the inside of these black holes, inside of this particular radius Rs of the star, considering as a spherical surface. The object is therefore lost to the outside universe, but its strong gravitational field alone will be felt by other nearby objects. So, how we feel such an object is the intense gravitational field is there for this object. So, if you consider a comet is coming from outside and it is passing nearby places of this black hole, its path deviated towards the black hole due to its high gravitational field. And from this, we can say that the deviation of the comet in its path is produced due to the gravitational pull of a black hole. That is the only method to detect the presence of a black hole. And this region of Rs is called event horizon. It is, you just consider a spherical surface of radius, Schwarzschild radius Rs, and that particular surface is called an event horizon. It is a mathematical surface of radius equal to Rs. The word event horizon means that any event within it remains hidden from view. You cannot see anything inside this event horizon. No event can be revealed outside within this event horizon. The resulting object is called a black hole. And one more thing, in a spherical collapsing star, all the material will simultaneously reach the center with a period of about 1 microsecond after crossing the event horizon. So the central core is having a high gravitational field. The every surrounding particle is attracted by the core. And if you consider the the particle coming to the center of the core, when it reaches the event horizon, suddenly within a fraction of a second, within 1 microsecond time, it will suddenly fall to the center of the black hole. So the entire mass thus shrinks to a point of infinite density, which forms a singularity. So what is the result? So now the center becomes high, dense and dense. And its radius tends to becoming a very, very, very less value. This point is the center of the spherical surface, and that particular center is called singularity. So we can define singularity. Singularity is a point of zero volume and infinite density where all the black hole's mass is located. It can never be observed. So imagine singularity is a single point. It is having no volume. Volume tends to zero. And its density tends to infinity. Density is infinity. Such a point is called singularity, and it lies at the center of the event horizon sphere. So you can see this green figure. This is the space-time curvature of the universe. According to Einstein, gravitation is produced due to this space-time curvature. If you consider a particle is moving around this region, what happens is automatically it falls inside the hole. So this is due to the intense gravity of the particle. So in this figure, you can find such a space-time curvature, and this part, the lowermost part, it is the singularity point. So every particle falls to this curvature and it reaches to singularity, and singularity becomes a very small point, and it is having a spherical surface. This spherical surface is called the event horizon. This particular radius is called the Schwarzschild radius. And so black hole singularity signifies the presence of black hole. This figure gives an idea about these 3 points. This is the singularity, this is the event horizon, and this radius is called the Schwarzschild radius, 2gm by c square. From equation 1, what is 1? Rs is equal to 2gm by c square. From 1, radius of the event horizon is proportional to the mass of the collapsed object. You just consider a sun. If sun is becoming a black hole, its Schwarzschild radius becomes 2.63 kilometer. It's very, very, very less. The minimum density attained by the material at this stage is 10 raised to 16 gram per centimeter cube. For a mass of 10 mson, this radius Rs is 27 kilometer, and density becomes 10 raised to 14 gram per centimeter cube. For a mass of 10 raised to 9 mson, the radius is 10 raised to minus 4 per second, and density is 10 raised to minus 2 gram per centimeter cube. When the event horizon has formed, light from within cannot move out. Light is trapped inside the event horizon. But the light from the outside neighborhood of the horizon will propagate. This will be strongly redshifted by the gravitational pull of the black hole. Both matter and light that encounter the event horizon will be sucked in. A black hole may capture mass from the surrounding space by the gravitational pull. Due to this, black hole will draw gas from the upper atmosphere of the companion stars. This gas forms a rotating disk around the black hole. So you can see a rotating disk around this black hole. Here these particles are attracted by the black hole from the nearby star. And you just consider 2 black holes come in contact and merge together. So what happens to gravitational field? The gravitational radiation becomes very high. Naturally, 2 black holes are having 2 event horizons. If they are merging together, an envelope of common event horizon is formed. That is, total surface area of new event horizon increases. That the 2 black holes are of equal mass m. So we are expecting m plus m, 2m mass. But the resultant mass m dash, it will be somewhat lesser than that of 2m. And a Schwarzschild radius is also not the sum, but it is somewhat lesser than 2 RS. So m dash is greater than root 2 m. So it is not equal to 2m, but it is greater than root 2. Root 2 means 1.414 times that of m. So if you consider our sun, if sun is collapsed into a black hole, then the black hole becomes only 3 kilometers in diameter. If the earth becomes a black hole, the earth becomes only 1.5 centimeter in diameter. You see, this figure represents the size of the black hole when earth is converted to a black hole. This is an imagination for finding its diameter. So this table gives what happens when Earth, the Sun, our galaxy, cluster of galaxies, closed universe becomes a black hole. Its radius is given here. So its radius becomes very, very, very small and density becomes very, very great. There may be 10 raised to 9 black holes in the galaxy. Most likely place to detect them is in the massive binary systems. Sirius A, Sirius B are binary systems. Procyon A, Procyon B are binary systems. And intense X-ray radiation results when mass is accreted by a black hole. So X-rays are coming from these black holes. If one of the components of a binary system is a normal star, while the other has become a black hole, former will move in an orbit around. The latter will be optically visible, but will emit X-rays. Cygnus X1 is an example for this. Thank you.